Hello and welcome everyone to this lecture. So, till the last lecture we saw how we can use Hyperledger Fabric in a test network and install some smart contracts as chain codes and do some transactions. So, in this particular lecture we will go through Hyperledger Fabric chain codes. So, we will learn about how we can write Hyperledger Fabric chain codes and how Hyperledger Fabric chain code transaction flow works. So, when we execute a transaction, what happens in a Fabric network, and then we will see how to write your own chain codes. So, the keywords for this lecture are Fabric, chain codes and Fabric transactions. So, what are Fabric smart contracts or Hyperledger Fabric chain codes? So, in Hyperledger Fabric, for making any transactions, first the types of the data, the rules and the processes through which these data will be processed must be defined, and that is defined through smart contracts. So, whatever business logic we want to write has to be defined through smart contracts, and in Hyperledger Fabric these smart contracts are actually packaged as chain codes. So, if you see this particular diagram, then in a network if there are two organizations, buyer and seller orgs, org 1 is the buyer organization and org 2 is the seller, then we would have a smart contract like this for an application which is used to handle cars. So, suppose these two organizations want to buy and sell cars, then this particular contract named as car contract will have several functions. So, here we can see there are three functions: query, transfer and update, and all of them are concerned about the data of different cars. So, here query car will simply get a car and return its details. Transfer takes a car and changes its owner to a different owner. So, transfer is actually when suppose a buyer is buying a car from the seller, then this function will change the owner from the seller to the buyer and update the new car details on the ledger. Similarly, update will update the different other values or other properties of this particular card and then save it back to the ledger. So, in this way any business logic can be actually programmed into a smart contract and deployed into the Hyperledger Fabric network. So, when we do a transaction in the Fabric network, how does how that transaction looks like? So, the transaction flow can be described through this simple diagram. Here in this example, we have one client C, then we have three endorsing peers EP1, EP2 and EP3, and then there can be one orderer or multiple orderers running Kafka or any other consensus protocol, and there can be other peers also which are not endorsing peers, but which are still participating in the Fabric network. So, when we do a transaction, it starts from a client. So, a client can belong to any of the organizations. So, one client of one such organization can actually start a transaction, and that transaction will have the client ID, the chain code ID, that is the smart contract which we want to execute or which the client wants to execute, the transaction payload or basically the arguments and parameters that the client is using to execute that smart contract, timestamp and the signature of the client. So, this transaction is sent to all the endorsing peers by the client. The endorsing peers receive that transaction and then they endorse it, and before endorsing that they first emulate or simulate that transaction on their own local copy of the ledger and see that after applying that transaction what would be the output. If they agree on the output or if they see that the output is fine as per the business logic, then they endorse that transaction and send it back to the client. So, in this way the client is receiving endorsement from all the endorsing peers, and now the transaction along with those endorsement is sent to the ordering service. The ordering service collects all those transactions and then put it in a block and send the block back to all the peers. So, by all the peers, it might be the peers which did not endorse the transaction. So, those are committing peers, and there might be peers who also did endorse that particular transaction, the endorsing peers. So, at this point this transaction has been mined in a particular block. So, let us see that how we can write Fabric smart contracts or Fabric chain code. So, in Hyperledger Fabric, Fabric actually provides you SDKs in Go language, Node.js or Java. So, we can use any of these three languages to write our smart contracts. So, this is somewhat different from Ethereum or Bitcoin, where if we wanted to write a smart contract, then we needed to use a specific programming language such as Solidity in Ethereum. Here these are general purpose programming languages, and we can implement any kind of business logic, as we will see. So, these smart contracts or chain codes when deployed run in a separate process from the peer. So, when we deploy the chain code, it will be deployed in each peer. So, each peer will have its own copy of the chain code, and these peers will be running them as separate processes. So, we will be using the Go programming language for this particular tutorial. However, you can use the Fabric contract API of the Hyperledger Fabric SDK from any of these languages. So, in Go, Node.js and Java, this particular SDK is available. So, let us actually start writing a smart contract and see how that works. So, till the last lecture we saw that we had downloaded the Fabric binaries, samples and images in this Fabric directory, and we can see the Fabric samples directory here. So, in the Fabric samples directory we have many examples and also the test network. So, we saw how we can run the test network, etc. So, we can go ahead and create our smart contract here. So, just create a new folder. We are naming this test chain code, and you can give any name of your choice. So, create this new directory. So, if you go inside this directory and open up a terminal window here, and now we can see that of course, this is an empty directory. So, if you do an ls, we will see that there is nothing inside it. So, let us start a code editor here. So, we are using Visual Studio Code, but you can use any IDE or text editor of your choice to write your chain codes. So, here there is no file. So, let us go ahead and create a new file, and we will be writing our chain code in Go language. So, we can name this file anything. We are naming it test chain code .go, and save this. Make sure that the extension is .go, so that we can compile it, and the name you can give any name. Fine. So, now we have to do some initial steps before we write our contract. So, in Go language we have to define a package. So, let us name our package as package main, and then we would need to import certain packages. So, the first thing that we are importing here is the FMT library. So, this would be used for printing and formatting the output when we print certain things and formatting strings. And the second thing we need is the Fabric SDK for writing chain code. So, that is called the contract API. So, you can see that Fabric -contract -API -go is the name of this package, and then from that we are importing contract API. Okay. So, let us start writing the chain code. So, first thing that we need to do is we need to define a smart contract or initialize a smart contract structure. So, we will write type smart contract, and this will be of struct contract API dot contract. So, now we have defined a smart contract type, and this will be providing the functions for storing and also retrieving different kinds of data in the form of key value pairs from the Hyperledger Fabric ledger. So, in the Fabric network, in whichever channel we will be deploying this smart contract or chain code, this smart contract will be able to store and retrieve data from that particular channel. Okay. So, the next step would be to actually define a function which is called init ledger. So, let us go ahead and do that. So, we will write func space. So, that is the way we define functions in the Go programming language, and then we would be passing this struct or type smart contract. Okay. And name of the function is init ledger, and the init ledger will take input a context. So, this context is actually contract API dot transaction context interface. Now, let us specify what it would return. So, it would only return an error if there is any error. So, the init ledger is taking only one argument, this transaction context interface, and the name of the variable is CTX, and it returns an error if any. So, what we would do, we would just store something, some dummy key value pair in the ledger when we call this init ledger. So, for doing that, we are writing ctx.getStub.putState. So, this put state function of the stub. So, ctx.getStub returns a stub. So, you can do stub.putState, and then this putState function actually stores a key value pair into the ledger. So, it takes these two arguments, test key and test val, and test key is of type string, and here I have just casted test val into byte array type. So, test val would be a byte array and this key is a string. So, it might return some error. So, we have just done error equal to this thing, and now if error not equal to nil. So, if there is no error, then we are fine. So, we can just return so if there is an error, then there will be a problem, but if it is not equal to nil, that means that there is an error. So, we will just return an error. So, fmt dot error f and pass your error message, and else. So, if there is no error, we can write else, or simply we can just type in the next line. So, let us type in the next line. So, we would just return nil because there is no error. So, we have defined init ledger which can be used to initialize the smart contract for the first time, and next the function we are going to define is create key. So, in this particular smart contract, we are just defining two very simple functions for storing and retrieving data. So, this create key function looks exactly like the init ledger function. However, we are adding another two arguments. So, first one is key of type string, the second one is value of type string. So, val space string. So, these are the two new arguments that this create key function will take, and we will be using this create key to just store a key value pair into the ledger. So, we already saw that how to store a key value pair in the ledger. So, in line 18 you can see that. So, similarly, we will store that. So, we will do ctx.getStub.putState, and we will pass the key which is a string, and we have to typecast the value to byte array. So, two brackets byte and inside the bracket val. So, this is just typecasting the value to byte array. So, the next function we are going to do is query. So, create keys for writing stuff into the ledger using put state. So, these both are writing stuff into the ledger. So, we are writing some key value pair into the ledger, and now query key can be used to read some data from the ledger and return that to the application. So, this query key will only take the key as argument. So, key is of type string, of course, the value would be retrieved from the ledger. So, for this we will be using similarly ctx.getStuff, but dot get state. Okay, so, ctx.getStuff dot get state, and it would take only one argument, which is the key. Okay, and then it might return some error, or it will return some value if it exists. So, accordingly we can just write val comma err equals or colon equals. So, it will be returning a value or and an error. So, let us first check if there is an error or not. So, if error not equals to nil, then that means that there is an error. So, in that case let us return that it failed to get value from the world state, and it should also, okay, if there is no error, then it should be returning the value. So, we will return the string which is value. Okay, so, in the function definition we need to also add that it returns a value. So, let us add that string type on that function definition. So, we will be returning the value and also the error, which is nil. So, let us add that type here, string and comma error. Okay. So, let us give it in a bracket, string and error. So, we are returning string val comma nil in line 40. So, we need to also return it in line 37. So, if there is an error, it will return an empty string. So, only quotes, empty quotes, and then the error. So, query key is ready. So, we have defined init ledger, create key and query key. Now, we need to write the function, the main function, which will be actually used to start the particular smart contract or chain code. Okay. So, we are defining the chain code as contract API dot new chain code, and inside that we would be passing new smart contract. So, this smart contract we defined at the top, right. So, now we have to check if there is an error. So, if error not equals to nil, let us print some error message fmt.printf and some message. And if there is an error, then simply return, or if there is a no error, then we would do we have to start this chain code. So, we have defined this chain code in line 44 with contract API dot new chain code, but in order to run this chain code we need to actually start it. So, we would go ahead and write we go ahead and start that chain code. So, chain code dot start, and this might also return some error. So, we have to check for that. Fine. So, if error not equal to nil, then let us print some message. Fine. So, at this point you can go ahead and save this file, and then we are moving back to the terminal. So, we have this go file. So, in order to compile it, we have this command go build. So, you see that it is writing that module not found. So, for initializing a module, we have to use this particular command go mod init, then a particular name in this format, some domain slash the name of the module. So, at this point the module has been initialized. So, if you try to do go build, it is saying that it is unable to find the package. So, no required module provides this package Fabric contract API. So, how do we install that package? So, remember we imported this package here in this code. So, we need to fetch this package Fabric contract API. To fetch that, there is a simple command which is go space get. So, you do that and press enter, and it will automatically fetch all the required packages in your files and install them. So, now we have to do simply go build again, go space build, and it is not giving us any error. That means that it is built successfully. You can do ls and check that the binary is produced there after compiling. But we won't be running it simply like this. So, we would need to deploy it in the Fabric network. So, to do that, first of course, we need to start the test network. Let us go into the test network, cd test network. Now, do /network.sh up, just the same steps that we followed in the last lecture. Fine, the test network is now running. So, we need to also create a channel. So, let us do that. Let us create a channel. Let us ensure that all the containers are running. So, 2 peers, 1 order, and now /network.sh and create channel. So, this would be creating a channel named my channel here. Fine. So, we have this channel ready. So, we can now go ahead and install the particular chain code. Okay. So, for doing that, we will be using the same script, ./network.sh and deploy cc command, and this -ccn is the name of the chain code. So, we are giving it key value chain code, and -ccp is the path where your chain code exists. Okay. So, if you go back to this directory again, then we have this test networks, and in that test network, so we are running network.sh. So, actually our chain code, this test -chain code is one directory above that the current directory. So, we have given /test chain code, and the language is Go. So, let us run this. So, it is now installing our chain code and giving with this name key value chain code. Okay. So, you can see PR lifecycle chain code install key value chain code .tar.gz. So, and before that you can see chain code is packaged. So, it is installing the chain code. So, it would take a bit time. So, it will install the chain code and also see that if the chain code is ready to be used. So, you can see that it is trying to query the chain code and see if it is working correctly. So, you can see at the end everything is successfully done and the chain code is installed. So, now we can actually test our chain code. So, for doing that, we will use the same steps of querying and invoking chain code. So, we are configuring these environment variables first, the Fabric CFG path, TLS enabled, MSP IDs, root certificate, etc. Now, we can go ahead and invoke the chain code. Okay. So, the same commands as per the last tutorial. Here you can see the name of the channel is my channel and the name of the chain code is key value chain code. The function we are trying to invoke is initledger, and it is not taking any argument. So, if you check this initledger, it only takes the contract API the transaction context interface, and it will save this test key and test value in the ledger. So, it is not taking any arguments from outside. Okay. So, we can see that chain code invocation is successful. So, as per the contract, it should be saving this test key and save the value as test val. So, we are querying this using query key function and passing test key. Ideally, it should return test val and yes, indeed we can see that it is giving us this value test val back. But if we try to query something else, for example nptel, then we can see that it is not returning anything, or rather it is giving us an empty string, fine. So, to save something, some particular key value pair, we obviously wrote a function, and that function is create key. So, let us try to invoke that. So, instead of init ledger, we will be passing create key, and it will take two arguments. Okay. One is the key name nptel, and then let us give any value. So, you can write anything here. So, blockchain for example, let us press enter. It says chain code invocation successful. Now, if we do the same query, let us copy paste this query. Then indeed you can see that it is outputting blockchain. So, all the functions are working correctly. So, we saw that how we can write a very simple smart contract which only saves a key value pair into the ledger. So, you can actually design any kind of smart contract by using only those get state and put state primitives. So, we started by defining a smart contract type here, and then we saw how we can define an init ledger function. So, actually in the recent versions of Hyperledger Fabric, you can also skip this init ledger function, and it is not mandatory. So, in the older version it was a required function, but now you can define your own functions directly. And then we used this get state and put state to define two functions, create key and query key. Create key is saving a key value pair, and query key is retrieving one from the ledger. And finally, we started our chain code in this main function, and we saw how we can use it using the same query and invoke commands. So, concluding, we saw that we can use Hyperledger Fabric chain codes and in general programming languages. So, unlike Solidity in Ethereum, we can use Go, Node.js or Java to write Hyperledger Fabric chain codes, and you can use these chain codes and you can use the get state and put state APIs to actually implement any kind of business logic. So, if you want to store some XML data, you can just convert that XML data and serialize that into a string and write that into ledger. If you want to store some JSON data, so you can also do that by serializing it into a string and writing that back to the ledger as a string. So, as a result, we can use these chain codes, and by storing the key value pairs in the world chain world state in the blockchain to implement any kind of business logic. So, in the next lecture, we will actually see that how we can access these smart contracts programmatically. So, now we are doing everything from the command line, but we need to see how we can actually integrate these smart contracts with decentralized applications and then use them to build dApps. So, that we will cover in the next lecture. So, thank you.